assisted suicide, okay? You use something the organism has to kill it. Here's the problem with our situation currently. There's actually a mutant, H. pylori, and he actually doesn't produce the enzyme. He lacks the ability. He's developed this mutation right where the enzyme would be produced, but it's not produced. So what happens? If you have no enzyme, you have no poison, and you have no death. So this guy survives. And he goes on and makes copies of himself through asexual reproduction, and you have a whole bunch of these guys, okay? And that's not good. And we got to come up with a new antibiotic to take him out. So, but notice what's happened here. Again, we knocked out an enzyme for him to survive. We didn't create an enzyme. We didn't create a new function. We didn't create some kind of micro machine that's going to do this. We actually broke something to make it happen. And I mean, this isn't the only way that you get antibiotic resistance. There's a number of ways. But I would argue every example I've read has been a loss of genetic information, not an increase. Okay? You're not going to go from molecules to man by going through this process, by breaking things. Here's a really powerful argument that I originally, when I originally discovered it, I thought, okay, this is it. This is the example of evolution in action, and what am I going to do? I got to become an evolutionist now. And then I started looking into it, okay? And I'm going to try and go through this example. This is Richard Lenski's experiment. Now, Richard Lenski has been doing a long-term evolution experiment. He started in 1988 with his bacteria. He's been growing them still till today, but as of 2010, he's had over 50,000 generations of bacteria. If we had 50,000 generations of human beings, that would be over 1 million years of human beings. So this is not a computer simulation. This is, we're growing bacteria in the laboratory and seeing if they'll evolve, okay? So what happened? Well, there was a headline, and this is what startled me. E. coli, he's growing these E. coli bacteria. They're actually in your body as well. They evolved the ability to metabolize citrate. And to you, that may not sound very exciting, but I thought, oh, they evolved the ability to do something. And it's metabolizing, like this is big. This is huge. Let's see what happened. So it turns out in an oxygen environment, aerobic conditions, the E. coli will not metabolize citrate. Now here's what they don't tell you in the article, if you go back and read Lenski's article. He won't tell you, at least not explicitly, that it has the ability to metabolize citrate, just not in this environment. If you go into a no oxygen environment, he can metabolize citrate. It turns out he can metabolize citrate in both, but what you need to do is get the citrate into the cell. Now here's the cool part. If you're in a no oxygen environment, you have a transporter, and he'll come and get the citrate and bring it into the cell. This guy doesn't have the transporter. That's the problem. He actually could metabolize citrate if he could just transport it into the cell. Now here's the cool part. He ended up getting a mutation that broke the citrate transporter. So instead of just working in this environment, it's working overtime. Now it's always making this transporter. And so what ends up happening is he's got the transporter now, and he brings it into the cell. I realize that might have been too quick. I know, even for me, I've read this over. So here's an illustration. This is the best I could come up with, okay? Here we have two night lights. Two night lights. Instead of no oxygen, I'm going to say no light. Instead of oxygen, I'm going to put light. Okay, let's turn the lights off. Hey, my night light comes on. You ever have one of these hall night lights? And you turn the lights out, and all of a sudden the light comes on? So it turns on in the absence of light. Now this guy over here, when my light's on, he's off, right? But what happens if something broke in here? Maybe a sensor broke. So now it's on all the time when my lights are on. Notice though, there wasn't any new function being produced. There wasn't, go back to the citrate example, everything was there. The ability to make the transporter, the ability to metabolize citrate. Now listen very carefully. This is 50,000 generations. This is equivalent to over 1 million years of evolution, and that's what we have. That's the best example. Okay? You need to understand this. That's 1 million years. When I start talking about whale evolution and they think it can happen in like 2-3 million years, and all the things that have to take place, it's not going to happen because this is our evidence. This actually shows the limits of Darwinism, not what it's capable of doing. Okay? In fact, Michael Behe's written a book called The Edge of Evolution. I saw Michael Behe talk in Toronto last week. If you don't know Michael Behe's work, he's kind of a weird theistic evolutionist, but his intelligent design work, Darwin's Black Box, Edge of Evolution, are pretty brilliant. So we turn the light on, and the light stays on, and wow. That's my illustration. So to go from a paramecium to people, that's my wife and brother, you need to actually increase genetic information. Here's paramecium. It has no information to make hair or eyes or lungs or anything else. If you're going to make these very complicated structures and systems, you need more information. We'll come back to that when we talk about intelligent design. Okay, so what are some other evidences for evolution? Well, the fossil record. Fossil record. When I talk to people about the fossil record, I want to go directly, as a strategy, to the Cambrian explosion. This is when 75 to 95% of all known animal phyla, all the animal body plans, vertebrates, invertebrates, and so on, all come into existence. In fact, and so maybe you're a young Earth creationist or not. It doesn't matter. You can use this argument because they believe, even if you don't, in the millions of years. Okay? And so what we find is, in about 5 to 10 million years, you have every body plan showing up in the fossil record. Okay? Now that is a geological instant when you consider the whole thing being 530 million years ago. Okay? So from 530 million years ago to 520 million years ago, you have all the major body plans. And we haven't discovered any new body plans. In fact, the ones that we discovered in here, some of them have gone extinct. So we have less in existence today. Okay? Here's the argument, though. If evolution is true, you would expect to see the fossils transitioning into these. But we go and we dig in the Precambrian rock, and we don't find the transitions. They're missing. It's like these just showed up in a geological instant. And notice, this is like the creation orchard of life, not like the tree of life. Even Richard Dawkins in The Blind Watchmaker says, it is as though they were just planted there without evolutionary history. Okay? And he actually goes on after that to say, and the creationists are going to quote mine me when I say this. And so here I am, using this quote. Because it's true. It really is true. And you could cite quote after quote showing that. So this is biology's Big Bang, if you want to call it that. All these creatures just showing up. Very powerful evidence against evolution for creation. This I don't think is strong evidence, but I just like to point it out that stasis in the fossil record is more common than any kind of transition or evolution. So organisms remain largely unchanged throughout their duration in the fossil record. Here's a coelacanth 400 million years ago, and here's a coelacanth at present, and they're virtually identical. This guy hasn't evolved or changed in 400 million years. Okay? It's one of those things that make you go, Okay? And so that's a coelacanth. We got a horseshoe crab 445 million years ago. There he is. And there he is today. Okay? Virtually identical. Lamprey, 360 million years. Hasn't changed. Okay? So there's things that make you go, why haven't they changed in millions of years? The missing links. In Charles Darwin's book in 1859, he writes that this is actually the most obvious and gravest objection against, or that can be urged against my theory. See, in his day, I mean, geology and paleontology were, to be honest, just early new science, but they couldn't find the transitions that he proposed. And there should be millions and billions of transitions. Okay, it shouldn't be like It shouldn't be this needle in a haystack hunt. And he believed that. And so here's a quote. I know this is a little old, but David Rupp actually says that, well, we now, he says, well, we are now about 120 years after Darwin, and our knowledge of the fossil record has been greatly expanded. Ironically, we have even fewer examples of evolutionary transition than we had at Darwin's time, because some of the ones that Darwin thought were good arguments actually have been thrown out. Okay, they don't use them anymore. I'll show you some that we don't want to use anymore. The late Stephen Jay Gould from Harvard, he's a paleontologist. He said the extreme rarity of the transitional forms in the fossil record persists as the trade secret of paleontology. The evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of fossils. Okay, this guy was definitely not a creationist, but he saw that there was a lot of transitions missing. He actually came up with his own modified version of evolution called punctuated equilibrium, where evolution works more in fits and starts than this transition. So Richard Dawkins, he's a slow and gradual evolutionist, and I would say, no, you're wrong, and Stephen Jay Gould would argue against him. Stephen Jay Gould, he believes it happens in jumps and starts, and I would say, no, you're wrong, and Richard Dawkins would argue against him, okay? I think they're both right in arguing against each other. So let's look at whale evolution. Whale evolution. Okay, so we have this guy here. He was discovered a while ago. I'm not going to go into all the nitty-gritty detail. I'm just going to show you a pretty powerful argument against whale evolution. Here we have Pakicetus. That's what they believe the original whales evolved from. Similar to like a tapir, or they used to think of like a wolf or something. The original diagrams of this, by the way, when they discovered the jaw, the artists, they get their imaginations going, and they drew him in the water, and he had flippers and everything. And turns out, no, he's got legs. He's a tetrapod. And so here we have Pakicetus. Over here, you have Basilosaurus. And so Basilosaurus is about the 40 million year mark. Pakicetus is around 53 million years, 50 million years, around there, okay? And then they started finding all these things they called transitions. So we have Ambulocetus around 49 million years ago. We have Remington-Ocetus, not the Remington shaver. He's at 49 million years as well. So these two are kind of right about here. You have Rhodocetus at 47 million years. Okay, and so they're just, wow, we're really finding evolution here. Now I could go through and show how these actually aren't good transitions. But here's what I'm going to show you. Recent evidence, okay? And this is where evidence really, like real scientific evidence, can just knock out a paradigm, okay? And recent evidence has discovered a fully aquatic whale jaw at 49 million years. So here we used to think this was our first aquatic animal, fully aquatic. Here we have these transitions, but only a million years after Pakicetus, or a couple million years after Pakicetus, we have a fully aquatic organism, okay? So these can't be transitions, okay? It has to be, the transitions have to be on this side, before the aquatic organism, okay? And so this is powerful evidence against all of these transitions. In fact, that means that to go from Pakicetus to a fully aquatic whale in about 3 million years, maybe 1 or 2 million years, in fact, you have to get, the blowhole. You got to reduce the hind limbs. You got to go from the ability to drink seawater, or adapt that ability, so change the kidneys. You got to build a tail fluke. You got to go from a tail that goes side